All right, let's dive right in. Today, we're going to put on our detective hats and take a really close look at the world of AI. We're launching an investigation to find where bias really comes from. And I'll tell you right now, the first clues are hiding in a place you might not expect.
So, when you think about AI bias, what's the first thing that comes to mind? Probably the algorithm, right? The code itself. But what if I told you the problem starts long before a single line of code is even written? We've got to look way earlier in the process.
Yep, that's right. The bias is often already baked into the raw data, the very stuff we use to teach our AI models. This data comes from the real world, and if the real world has inequities, our AI is just going to learn to automate them.
And this is just so crucial to get. Think of it like a doctor trying to treat an illness. You can't just manage the symptoms, you have to find the root cause. Well, in the world of AI fairness, that root cause is almost always buried deep inside the data.
Okay, so from here on out, we're going to treat our data set like the scene of a crime. The potential crime here is discrimination. And the clues, well, they're hidden among all those data points. Our job is to be the data detectives, to search for any shred of evidence. And to crack this case, every good detective needs a toolkit. So let's open up our bag and take a look at the 4 essential tools we absolutely need to uncover these hidden clues of bias. These are the core techniques for any real investigation.
So, inside our toolkit, we've got 4 main instruments: historical pattern detection, representation bias detection, statistical disparity analysis, and proxy variable identification. Let's break down what each of these really helps us find.
First up, historical pattern detection. This is all about understanding the story behind the numbers. See, AI models are fantastic students of the past, but if that past includes ugly stuff like discriminatory housing practices, well, the data is going to reflect that, and the AI will learn to repeat those same biases if we're not careful. Next, we have representation bias. This is what happens when our data just doesn't look like the real world. For example, if you train a facial recognition AI mostly on pictures of people with lighter skin, it's going to be absolutely terrible at recognizing people with darker skin. It's that simple. This tool helps us spot those imbalances.
A really easy way to think about this is to compare it to a political poll. We all know that if a pollster only surveys people in one neighborhood, their predictions for the whole country are going to be totally wrong, right? It is the exact same principle for AI. If your data doesn't properly represent all of your users, your model will be fundamentally broken for some of them.
Our third tool is statistical disparity analysis. Now, this is where we go from having a hunch to having cold, hard proof. It's the math that tells us whether an observed difference between 2 groups is a real, statistically significant pattern, or if it could just be random noise. This is actually a lot like the A/B testing marketers use all the time. When they use stats to prove if changing a button color really causes more people to click? We're using that same statistical logic, but to see if being part of a certain group is significantly associated with getting a different and potentially unfair outcome.
And the last tool in our kit? Oh man, this one is maybe the most important and definitely the sneakiest: proxy variable identification. This is about finding the culprits that are hiding in plain sight. You might think you're doing the right thing by removing a sensitive feature like race from your data. But what if you leave in zip code? In many places, zip code is a huge stand-in, a proxy for race, and the AI is smart enough to figure that out and discriminate anyway.
This is how bias gets laundered through data. You take out the obvious, explicit attribute like race, but the bias just creeps back in through something that seems totally neutral. It could be a zip code, a person's favorite music genre, even the type of insurance they have. These are the proxies, the secret stand-ins for the info you tried to hide.
And here's a crucial tip for all you data detectives out there. Bias almost never lives in just one category. A model might seem fair to men and fair to women when you look at them separately, but it could be deeply unfair to a very specific intersection, like Black women. You have to dig into these intersections to find the most harmful biases.
Okay, enough theory. Let's see how this detective toolkit actually works in the real world. We're going to dive into a case study from a healthcare company that we're just going to call Health AI.
So Health AI built this AI with a really great mission: to predict which patients might miss their appointments so the clinic could proactively help them. But pretty soon, the staff noticed a disturbing pattern. The AI was flagging patients from low-income neighborhoods at a much higher rate. It was time to investigate. So the data science team pulled out their toolkit, and what they found was evidence at every single turn. First, historical bias. The data reflected the simple truth that poor patients face more barriers to getting care. Then, representation bias. Their dataset was seriously short on non-English speakers. They also found a clear statistical disparity, with risk scores being way higher for the lowest income groups. And finally, they found the proxies. Things like distance from the clinic were just acting as a stand-in for poverty.
And here's the smoking gun. When they actually ran the numbers, they discovered that the predicted risk of missing an appointment was a staggering 35% higher for patients in the lowest income group. This wasn't just a hunch the staff had. This was a hard statistical fact.
And that's when it hit them. Their AI hadn't actually learned to predict who would miss an appointment. It had just gotten really good at using proxy variables to identify which patients were poor. It wasn't predicting behavior, it was predicting poverty. So what did Health AI do? They didn't just tweak the model and call it a day. They learned a huge lesson from this. They realized that this work isn't a one-time fix. It's a constant, unending watch. They actually built their detective toolkit directly into their entire workflow. So now every single dataset gets audited before a model is even trained. The system automatically checks for representation, it runs statistical tests for fairness, it flags potential proxies, and most importantly, it acts as a gatekeeper, blocking any potentially biased model from ever getting deployed.
And this is the lesson for everybody. A manual audit is a good start, but it's just not enough. To build AI responsibly, bias detection has to be an automated, continuous part of the entire process, from the moment the data arrives to the moment a model goes live.
Ultimately, this whole thing represents a huge shift in thinking. The goal can't be just to find and fix biased models after they've already been built. The real goal has to be to create systems that prevent biased models from being created in the first place. It's about proactive prevention, not reactive cleanup. So, we've learned how to be data detectives, how to find the clues and identify the problem right at its source. And that is a critical first step. But it immediately raises the next big question. Once you've found the bias, what do you actually do about it? How do you start to fix it? Well, that's an investigation for another time. Thanks for joining me.